The SPA5 amplifier is a very good high-powered amplifier for general rife service. In this case, the amplifier has been installed with the proper heat sink, everything is connected, and it's a good-looking system that should work quite effectively. Sometimes, though, you tend to have problems with them and they do need repairs. Let me offer my apologies here for some of the camera shake you will see in the later part of this video. It was rather difficult to hold the camera with one hand, keeping everything in frame and at the same time reaching over to control the frequency generator without looking at it. In this video, I'll show the normal operation of the LEDs when power is first applied to the board with no audio signal. Then we'll show the operation of the LEDs when the audio is applied and everything is working normally. I'll also show the waveform converted from sine wave to square wave, as well as the RF output pulses from the amplifier. You don't have to apologize for the condition of your amplifier. Here's an example of one that came in for repair a while back. As you can see, it's in rather rough shape. The person who had the amplifier attempted to replace some parts in an attempt to upgrade the amplifier. Unfortunately, he wound up doing some damage to it, including breaking off one of the terminal strips, screws that actually hold the output MOSFET in place. Because of the damage done to the board, I declared it unserviceable, and the amplifier was replaced with a new one. You can see the interesting modifications that he did to the board, and also you can see underneath the board there was some rather rough repairs. Here's a 7812 voltage regulator on your circuit board. I did not bother to straighten it out as far as the vertical mounting goes because it'll work fine the way it is, and any version of that regulator will work just fine as well. I did clean up the bottom of the circuit board a little bit and applied some clear sealant to keep moisture from being absorbed into the circuit board material. I did take the liberty of readjusting the heat sink on the regulator so that the heat sink would sit vertically. This is just part of my OCD telling me that that's what I needed to do to make everything happy. So that's what I did. Now, looking at the oscillator, during shipment, it vibrated out of the socket. This has happened with these metal-cased oscillators before, so I reinstalled it in the socket and put a small twist tie wire around it to keep it from vibrating loose. Feel free to remove the wire if you want to replace the oscillator. You won't need the wire once the board is mounted back in its enclosure because it'll stay in the socket as long as it's not vibrated. Now, regarding 74HCT14, you had a Fairchild chip in there. I tested it. It seemed to work fine, but I did replace it with a TI chip for a couple of reasons. First of all, the circuit was designed to work with the specifications that the TI chip has. The Fairchild specs are just slightly different, and although it does work fine, I wanted to make sure that it's going to continue to work fine, and since that chip was also marked as used, the Fairchild chip was, I put in a new chip in there. Also, take a look at the chip, and you notice in the upper left-hand corner is the TI logo that's been laser embossed on the chip. Remember that because we're going to have a discussion in a couple of minutes here about the different types of ICs that are available, as in fake and real ones. When I received your circuit board, I inspected it, and upon trying it out, I found out that it just didn't work at all, no matter what kind of a signal I sent into it. It pretty well agreed with what you told me in your note. Okay, so on this picture, there are 6 integrated circuits, NE5532s. The 2 on the left, far left, are the ones that were in your amplifier. The 2 in the middle are 2 more that I purchased online, and the 2 on the right are genuine chips from Texas Instruments. Came directly from TI. Okay. The 2 on the left don't work at all. They're basically dead. The 2 in the middle don't work at all. They're basically dead. And what's happened is you and I both got a hold of some chips that are apparently fakes. I bought 100 of the chips that are in the middle, and I tested 100 of them, and 2 of them worked. The other 98 were just junk, didn't work at all. This is a problem. There are some bad ones out there. You may have gotten some bad ones. So anyway, I'm returning the bad ones to you, but they don't work. So you've got 2 new genuine TI integrated circuits in your board. So that should fix that problem. I tested your board after reinstalling the chips. It meets all the tests. Everything works fine. It produces full output. It does everything it's supposed to. So if you have a good signal and good power to it, everything should work fine. And in the next stage of the video here, I will show you the actual audio conversion tests and the operation of the LEDs. Okay, here's the SPA5, and I'm going to turn the power on with no signal applied, and you'll see the LEDs go through the normal startup procedure. Here we go. Okay, that's correct. That indicates everything is working normally. Now I'm going to turn the audio signal on, and you'll see the LEDs power back up again when the operation is complete. There we go. We have a good audio signal indicated by the blue LED. The gate is open and the frequency doubling mode is on, indicated by the green. The 2 red LEDs indicate the driver stage is working, and the yellow indicates we have power, drive power, going to the output MOSFET. Okay, now the board is powered up with no signal applied. We're sampling the frequency converted signal from sine to square wave at test point number 1 here. And we're looking at the RF output, which comes out of the circuit board over here, through this coax cable, to this sample. Part of the sample comes out here, goes to the oscilloscope and shows up as a red line on the scope. The yellow line is the audio signal turned into a square wave. When we turn the function generator on, you'll see the signal pop up on the square wave. There we go. That's converted to a sine wave. Now, it looks jittery on there, but that's an artifact of digital scopes. It doesn't synchronize properly to the waveform in this particular case. I've got the same scope connected to the same test point here. Different scope, an old Tektronix analog scope, and it displays the waveform very nicely and cleanly. So that's one of the advantages of an old analog scope. It can give you an indication of what's going on, whereas the digital scope doesn't always show the same thing. So that's just an indication there. Now, when I turn the high voltage on, which I'm going to do now, you'll see the red line show up indicating that we have RF power coming out. And in fact, if we take the scope and change the centering and then expand the sweep, you'll now see the individual RF pulses. They're not synchronized on the scope because we're not too well synchronized on it. I'm not locked onto that particular channel. I've got to use a different setup here if I want to see the wave stable. Maybe I can do that. Well, I was not able to get the scope to lock onto the RF pulses, but in the end, everything worked out fine. Your amplifier tested just fine. It drives the test bench STW20NK50Z to a full 500 watts output peak power. No problems at all. It works exactly as it's supposed to. So your board is functioning perfectly, just the way it should at this point. So all you need to do is to reinstall it, and if all the connections are good and the power supply is good, everything should work just fine. So that is basically the end of the video.